What's up, guys? Hope everyone's doing good. This is going to be a long video explaining most of the details of my system. Some things will be kept secret, but not everything. The most exotic transmitter model I have does feature exotic components, and the models I sell do achieve very interesting and very insane effects. So as you know, no one really builds a Tesla coil the correct way. Your ideal Tesla coil is just as wide as it is tall. The length would be your voltage, and the diameter would be your amperage. And if you want to get massive amounts of RF out of your coil, all you do is slap a bridge rectifier on your primary, and you can harness amperage out of that. I showed that in my older videos. I'm not going to get into that in this video. I demonstrated that in older videos. This is kind of a video that explains the theory of how it all operates, along with demonstrating the extreme distance I get with the system. As you see, this device is very simplex in nature. It doesn't produce massive wasteful sparks like other people do when they build a Tesla coil for giant sparks. They build tall, skinny, untuned coils that produce massive sparks that are complicated, have spark gaps. You don't need any of that. You can make it all solid state. And if you focus on just the principles of how it's constructed, you're in business. You make the thing nearly as wide as it is tall, you're automatically nearly tuned. And the thing operates very power efficiently. So the primary is 8-gauge wire, and we got 4 turns. But the turn count doesn't really matter. You go by ratios. So the secondary you can't see, which is underneath this. It's coated with dielectric transformer tape, and I believe it's some kind of Kapton. So yeah, there's a secondary underneath here, which is 4 inches long, and it's made out of this magnet wire over here, 26 gauge. Kind of thick, because a proper Tesla coil doesn't use very thin wire. It uses medium gauge wire, and the amplification, or the resonance factor, comes from the very high Q of your coil and your transmitter. You're getting a voltage and current gain from the high Q factor of your coil. So anyway, the proportions are as follows. The primary is 1/4 the size of the secondary. The extra coil, which is a bucking coil wound in the opposite directions to the primary and secondary, is 2 inches long, half the length, so half the wavelength. And the ideal ball size, your dielectric antenna, should be 1/4 the size of the system, half the size of the system, or a full size of the system. So feel free to play the video back and repeat that. Everything is done in ratios, and quarter harmonics, half harmonics, and full wave harmonics. You stick to those principles, you can scale it up or down any way you want. So that gives you a pretty good framework to build your device. Now, this is a simple modified Slayer circuit. The models I sell, compared to the personal model I have, they nearly do the same thing, except the personal model I have is much more power efficient, and I feature more exotic components in my personal model. The ones I sell can still do some pretty damn remarkable things. The range can go up to 2,000 feet, the wireless power range, with a tuned coil, a receiver coil. And why is that? Well, the device gives the illusion of wireless power. What we're really doing is we're transferring our power through the earth. We're sending a transmission of high frequency RF through the earth. And for those who don't know, high frequency power pretty much experiences a negative resistance, which means there's no loss when you transmit it from point A to B. It can actually experience an energy gain, similar to how multiple waves in the ocean can build upon each other until you have a rogue wave. The system is an open system. So people ask, where does the energy gain come from? Well, the energy gain comes from the environment itself. It's an open system. I use exotic nonlinear components that feature negative resistance. I use avalanche diodes, and I use germanium point contact transistors. And I'm saying too much in this video, but people want to know the exact science behind it. I'll tell you the exact science. It is a open system using nonlinear electrical components, and we don't have to obey Ohm's law because we're dealing with high frequency RF in an open system with nonlinear electrical components such as avalanche diodes, negative resistance, and germanium point contact transistors. And we also add the earth itself to our device when we ground it. So I'm going to turn it on and show you what it can do. This is the model I sell. It's $350 plus shipping. I'll repeat that, $350 plus shipping. I just have it sitting in a little glass plate of water. You don't need to do that. I like to operate it on very high power levels for testing. That just keeps it cool. That's completely optional. The ones people get can only go up to 24 volts for safety on the DC supply. It's fed with a DC supply. You get a mini one, and it only goes up to 24 volts. And the reason for that is it's the ideal operating parameters. You can buy a bigger supply and experiment. You'll just have to be careful. You could blow this chip if you're not careful. It can only handle, I believe it's 5 amps at the base, but your collector current is what will blow first. So you have to have, it's best not to feed it with more than 1 amp. You want to keep your power consumption under 1 amp. Anywhere from 0 to, say, 60 volts, you're screwing around. So, and eventually I will get much bigger transistors. I have them coming to me from a company. They give me a lot of exotic components. So anyway, if you're screwing around, you could blow that chip very easily. This thing was not designed to shoot off sparks. If you bring a ground wire near it and touch it to the ball, you could also blow the chip that way. That's not what this unit was designed to do. This unit was designed to maximize the radiant energy effect and also output high amperage from a bridge rectifier hooked to the L1. Now anyway, I'll turn this on. Well, before I turn it on, you'll see that this receiver coil I have here is not lit in any way. People ask, how is your receiver coil lit when you turn your transmitter on? Well, it's grounded to the earth of my heater down here. The wire just connects to my heater. It's earth grounded. And I'm going to be going into a lot of details on how it works in this video. And the other wire, which is right here, connects to the isolated metal of my desk. So what's happening is the isolated metal of the desk acts as an antenna, and this wire just connects to the other desk, because I actually have 2 desks here that are just sit side by side, as you can see. So this coil, completely removable. I'll do these tests in other spots around my house, and I'll show you how efficient the system is. I will turn the transmitter on. Oh, and this is just a ground connection wire. I don't even need that up here for this test, except for when I want to go long range. My wireless power range is up to 2,000 feet, and I confirmed that with my research partners and my friends. We demonstrated that in the field. We were blown away. We had less than 30 watts of input power to this thing, and we could light up as many lights as we wanted with separate grounds up to 2,000 feet away. Anyway, I'll turn it on, slowly turn it up. We'll see what 5 volts does for us. Transmitter is on at 5 volts, less than 110 milliamps. Do we have activation at the receiver? Yes, we do, and it's pretty bright. And I didn't even hook up my amplifier stone to that. And for those who don't know, look up how crystal radios work. certain stones act as diodes and amplifiers. If I touch this stone to part of the coil, it'll probably get brighter in a certain spot. Takes a lot of tuning. Not sure if it's showing very well. It would definitely be more visible if I could turn the power up a little bit. So we'll do 10 volts. And see what happens. So that's much brighter now. It's a little bit brighter when I touch the amplifier stone to it. And I found this in a local river next to me. I knew the stone that I was looking for. I might as well just tell everyone what it is. I was going to keep it secret, but I figured I told everyone so much already. And you want to know the science behind it? The stone is called diatomaceous earth. It's made from a bunch of sea creatures that like die and become fossilized over time. It almost looks like plaster, but it's not plaster. So you want to get something called diatomaceous earth. And you can get it as like a powder form or whatever. Sometimes it's a stone. Or you could make your own as a powder. You mix it with like a little bit of cement, diatomaceous earth, and quartz sand. And you have one hell of an amplifier stone. But anyway, that's not really even needed unless you're trying to receive massive amounts of... If you're trying to receive 3 to 4 times more power than your transmitter is giving off, you would probably need those materials. But anyway, people want to know how I got the range up to 2,000 feet. The range goes up to 2,000 feet when I take a receiver coil built almost identical to the transmitter. Now, I don't know why this is. So, this was the Mark II version of the transmitter. I'm going to use this as a receiver coil. And this is the interesting thing. This will not work if there's a ball on top. If I add a ball on top, it will kill the effect. Now, to get the range up to 2,000 feet, I grabbed my ground wire here. Which, as you can see, it's literally just only the earth ground right here of your plug. So, I connect my earth ground right here. And I will connect... Actually, I don't like how long the wire is. I'm just going to clean it up. So I was doing a lot of building in here. And it's tough filming one-handed. Anyway, I'll connect to the earth. So as you see, it's our earth connection. And to increase the range up to 2,000 feet, that's the furthest we tested it was 2,000 feet. Could be further than that, we don't know. You earth ground the primary of your receiver. So it's literally all there is to it. You can move it, it's wireless. I earth grounded that. And now this is very bright. And my range increased. I'll try and show that effect. I will connect and disconnect the earth ground. And hopefully that will you can see the brightness difference when I do that. So earth ground, disconnected, earth connected. See that? It's getting brighter each time I disconnect and reconnect the earth. Hopefully that's showing okay. Now just doing this. Now for some reason doing this gets the range up to 2,000 feet. I'm running 10 volts, a little over 300 milliamps. And if I want, I can get enough received power here to run a 120 volt LED bulb. So now what I will do is I will disconnect from this spot. I will disconnect from the heater. And I will take this receiver coil and I'll bend your mind. How can something that's consuming, right now I believe it's 15 watts of power, maybe 15 or 20. But you know what? I know where this works. I can connect this to my heater down here. Or I'll connect it to my bathroom sink. We're going to do a bunch of tests. I'm going to go outside too. So now I connect this to my bathroom sink. And it all is about tuning. And I should have rehearsed this. I have to do a little bit of adjustments here. We will turn you up to, we'll do 30 volts. Now I know for a fact we should have extreme wireless power at good range. Interesting, I'm having trouble getting that to light. Oh, no, it's lit. Okay. Oh, it was where I had it connected. See, sometimes I get tired and make mistakes too. Anyway, we got that lit. I know what it likes now. We will walk to my kitchen. Messy. Connect to here. It'll probably light. Yeah, it lights out here too. It is lit. I can probably get it even brighter by connecting up here. Turn that light off. So yep, full intensity in my kitchen. Get that plate out of there, it looks gross. So I am in my kitchen. It is lit between the oven, which is acting as ground, and this aerial capacity, which is acting as an antenna. Now I will go outside, and I'm not even sure if this effect will work with the transmitter I constructed, because the one I constructed isn't the one I personally use. That's the one I'm selling. So I'll get my shoes on, and I'll do a test outside real quick. I'll show you some things that'll absolutely blow your mind. Get my jacket on. Let's put you down here for a second while I get my jacket on. This is going to be a long video of me demonstrating things and talking and explaining how it works. So I'm going to grab a few things I might need. Transmitter is on, and I want to be guaranteed our signal reaches up to 2,000 feet. So 40 volts, 1.1 amps. That's what's being fed into the transmitter. Now for this, I will need my graphite crucible, because graphite is a very exotic property. I believe I have everything I need. Okay, so we're going to take my receiver coil here, and we're going to demonstrate all the locations it will light up at outside. You can see there's nothing in it. Those are my chickens. They're excited to see me. How you doing, birdie? So first check, I'll hook it up to the gutter here. And I believe I connected this part to the gutter and it lit. And as you see, the light is lit just off my gutter. Just off my gutter it's lit. I'll remove the connection while showing the light, trying to show the light, and it goes out. I'll connect that up again to my gutter. The light is lit. Hopefully that is visible. If I connect this into the earth ground, which is wet, the light gets brighter. You see that? And I'll put my piece of graphite here, and look how much brighter it gets. You see that? See that? All I did was put my piece of graphite on the earth ground. There's nothing in it. It's a piece of graphite right here. You see that effect? Hopefully you can clearly see that effect. It is very bright outside, but that light is lit. Next, I will take my receiver coil. I will go to my water faucet. Now, I thought electricity takes the path of least resistance. Why is it I can hook this up to my water faucet and it also lights that way too? See that? Lit connected to my water faucet. And these effects are very demonstratable at night. I should show this at night too. So that is lit at my water faucet. Now I will go, this is over 500 feet away. I will walk over 500 feet away to my off-grid solar. This solar shed is completely off-grid. Anyway, I'm walking all the way to my solar shed. Okay, I'm in my solar shed. I have my receiver coil. And it's lighting just in this area, just for me touching it. You see that? And when I had my friend over, I had him turn the transmitter. He was toggling the transmitter off and on, and when it was off, this would not light. So anyway, I'll put my plane of graphite right here. I'll connect to my plane of graphite Okay. Graphite wants to be connected with this one. As you can see, we're pretty bright. All I'm connected to is my piece of graphite and my finger. And I'm grounded. Graphite's acting as an antenna. I'm acting as the ground. I'll grab an earth wire connection. This is an earthed wire that connects to all these ground rods. I will connect to it. See how much of a difference that makes when we properly earth it? So we are receiving our transmitted power from the earth. If that's not an open system, I don't know what the hell is. I can get it really bright, I know that. I'm try and tune it. Okay, I got it really bright. And I also have these little wireless receiver lights with me. Check this out. Are you not blown away yet? This is how much radiant energy loves graphite. This is going to be a long video of me telling you everything I know. Look at that. Just because we're in proximity to the coil, we're witnessing a magnetic resonance energy duplication phenomenon. I can probably even touch this to dead batteries. These are old dead batteries. And look at that. It is receiving our RF radiant energy from the earth. Seems to like the negative terminal, not the positive. Very interesting. Another chunk of graphite. Depends on the location where you put it, where it will light. That's lit really bright. Everything got brighter when I did that. That's interesting to note. I have two bright lights now. So the resistance is probably going negative. For that, because that is getting brighter and this gets brighter when I better earth ground it. Can you see that? And those who want a good look at this thing, that's how it looks. My exotic RF diodes. Now anyway, I suppose I'll tell you what I learned. What I learned about radiant energy and how to transmit radiant energy and how to harness it is that if you put certain materials, certain minerals, certain crystals, certain solids near a high voltage source, pulse DC like a Tesla coil, if you put these certain materials near a Tesla coil, the material themselves will emit radiant energy to the point of extreme overunity and excess energy generation. Just the fact the material is sitting next to the Tesla coil, or in the Tesla coil's field of influence, will cause the atoms of the material to vibrate or go into some type of like super resonance where it emits tremendous amounts of radiant energy that can be converted into usable DC electricity. What I'm essentially telling you is we can create devices that power themselves forever. The only thing I'm not sure of is would it work in space, because you need that Earth connection, like the connection with the Earth itself. Imagine if your ship was big enough, it probably would. So that's pretty damn bright. And that's literally lit from a big chunk of graphite that sits up here as an antenna. As you see, it goes out, it gets dim when the graphite antenna is messed with. Loves graphite. So graphite, diatomaceous earth, quartz, all seem to kick off extreme radiant energy when near a Tesla coil, or when used as an antenna to receive the radiant energy from a Tesla coil. And look at that. Just gets brighter. Now I'll start walking back to my house. I'll take everything I needed. I'll disconnect. Well, actually, before I do that, I'll do some more experiments, just out of curiosity. I want to see if I can get this to light up in random spots on the Earth. Should be able to. I'll just put this right here, and we'll see what happens. Although that's an antenna, that has to be isolated from Earth. I'll try and do this experiment. Maybe more outside. I just need an isolated plane to put it on. Well, no, that could be conductive. Try and light it off this old metal trailer. See what happens. The paint should... Oh, here we go. We got some wood on it. That should insulate it. Now, I've never tried this test before, so we'll see what happens. My antenna is on non-conductive wood. All I need is a good ground connection. Nothing, not lit. Not sure if that's lit or what. Probably be best to test this at night, but we are not lit over here. Nothing. Did that... I thought I saw that flicker. No, maybe not. Anything? Nothing. We should probably, for this to light, would probably need a lot of ground rods in the earth. Okay. Try and move this somewhere else. It is tough doing this one-handed. See if I can hook this up to my wood stove and get it to light. Nothing yet. No, nothing. And I don't like filming failed effects in videos, but I suppose it's showing the reality of things. I like to film the video once I know that it'll work, and I've tested it before, but it's just interesting that there's something about this spot that it loves. And now there's no form of electricity in this spot at all. So what about this spot does it love? Do you see that? There's something about this spot. Is it the fact we're on concrete? I need to connect this wire here. I know this video quality is probably so bad. But I'm filming things one-handed. I'm just one person. I was up most of the night building orders for people that ordered the transmitter kits. Anyway, here we are, lit again. But that's old news. So I'm over 500 feet away. As you can see. I'm connected to... That's bright. That's really bright. I'm gonna get my earth connection again. All this is my storage shed too. All the large things I get donated to me, I just throw in this shed. Okay, our earth is connected back up again. We have our power being received over 500 feet away. Now I'm going to leave this here. Now I'm going to go to my room and I will shut the transmitter off. And we will see this will go out. There's something about this spot. Look at that. Just from putting a piece of graphite there. Really remarkable. Anyway, I'm gonna go to my room and shut the transmitter off. Again, 500 feet away. No mains here. Try and give you a peek of the roof of the solar shed. There's the roof of the solar shed. Nothing but solar panels. Oh. And yeah, we're heading back to my room. And this shed is run by an off-grid inverter, which is off. Walking back to my room. I'll shut the transmitter off and return to the shed to show you that the light will be out. Hello, bird. Want to say hello, birdie? How you doing, birdie? How you doing? Love saying hi to the birds. Okay, we are returning to my room. Also, these little things usually light up on metal too, at good range. So we're gonna go to my room. We're gonna shut off the transmitter. Before I do that, look at the insane range and efficiency. I don't know of any device in the world that's that small and that efficient. If it exists, it's probably locked away in a lab somewhere. And again, it's due to the proportions on how it's built. We're just being flooded with radiant energy from this transmitter. So, I'll shut it off. this off. And just so there can be no doubt, we unplug the positive. We will now make the long 500-foot walk back to the shed. It's over 500 feet. Just to show you that the light is out. The receiver light. The things we do for science and proof and videos. Should have filmed it with some of my friends, but they don't want to be on camera. How you doing, Bert? Kind of jog there. Okay, we're back at the shed. The light is out. So there you go. There can be no doubt our power was being received from the transmitter, which is remarkable. Over 500 feet away. I think this is where I'll stop this video, because it's going on long enough and you've seen everything. So I'm going to stop it there, and if you feel like donating to this research or our research group, our GoFundMe link is in the description, and thank you all who support us. Stay creative, everybody.